Thank you. So my name is Ben Parees. I'm a lead engineer on the OpenShift project. Just quick show of hands, how many people are familiar with OpenShift? Excellent. Okay, so for those who didn't raise their hands, OpenShift is a PaaS built on top of Kubernetes, adds some developer capabilities for building and managing your applications. So what we're going to go through today. First off, I want to apologize because yesterday Kelsey opened his presentation by saying you should not start with JSON or YAML. You should be able to not use that. There's a lot of JSON and YAML in this presentation. However, we are trying to make it so that the actual users don't have to experience that, but you will be using YAML and JSON to make things that your users will then consume. So I'm going to go through the OpenShift template specification, which we initially created to help make that developer experience easier, and what are some of the use cases for those templates, and then what's going on in the Kubernetes space with regard to templates. And then finally, I'm going to wrap it up with a couple other technologies that you might want to consider that provide similar capabilities in different ways. So what were our goals with the OpenShift templates? Well, the main goal was that we wanted to encapsulate all of the components of your application. So you have your service, your replication controller. In the case of OpenShift, we add some additional resources, build configurations, deployment configurations, routes. So we wanted an easy way to have all of that in one place so that you could stand it up without having a bunch of different files or forgetting a piece. Also being able to reference those things back and forth so that your service and your replication controller, since they have to have labels in common, being able to have that all tied together in a convenient way. We also wanted to have common labels for those things that are constructed from the template. And that way you can then manage and see everything that came from one application as a unit by doing a selector on a label. The second piece that we want to do was make it parameterizable. So you've created this great thing. It's a really cool application. You want users to be able to use it, but there might be small tweaks in how that gets used by each user. And so we wanted to make it so that you provide that template, and the user, when they go to use the template, they can configure it a little bit. How much memory do I want it to be able to use? Maybe I want to change the actual names of it. Maybe I want to be able to stand this up 3 times in one namespace, so I need a slightly different name so that things aren't colliding. So let's make that so that you can just provide that configuration and not have to worry about anything else and get it reproducibly deployed. We also wanted to be able to share those common values. So again, the labels between a selector and a replication controller. We also had things like database passwords. So if you're deploying a database service and an application, they might need to share a password. Let's make it so you specify that in one place. They're synced between all the components. Everything works. And then finally, our last goal was we want to fit with the Kubernetes API model. So we wanted it to be a JSON or a YAML syntax. We wanted it to look like an API object, just like a service or a replication controller or any other common Kubernetes object. And then that enabled us also to use the CRUD storage system and actually store these things in etcd, use the REST APIs that exist, and manage them just like any other resource object in the system. So what kinds of use cases do we use these templates for? As I mentioned, defining the replication controller and the service together so that the service is selecting on the things created by the replication controller, the right pods. We wanted to parameterize things like replication counts or memory limits so that, again, based on how you're deploying it, you can set the configuration appropriately. I mentioned earlier sharing environment variables. We're currently using passwords in environment variables. Really, you want to be using secrets for that. You can do that as well, but it was a little bit simpler for some of our cases to just use passwords at the time when things were a little bit less mature. In our case, because OpenShift introduces build configurations, we want to be able to point to the source repository. So you can define a build configuration that's going to pull source down from GitHub. Well, if you define a generic framework for building Node.js applications, we then want a user to be able to take that template that knows how to build a Node.js application and let them put in their Node.js GitHub repo. And they don't have to know anything else except where's my GitHub repo, instantiate that template, and get their application up and running. And then finally, we wanted to be able to parameterize the names of the resources we're creating, again, so that you can repeatedly deploy it, perhaps within the same namespace without collision. Okay, so here we jump into all the fun JSON stuff. I promise there's a more interesting demo coming later, but first I wanted to go through how you actually write one of these OpenShift templates. So as you can see on the left, there is, it looks just like any API object you might be familiar with from Kubernetes, except that the kind is a template. We've got some generic metadata. We introduced some specific annotations that our UI uses to give you a better experience. So we have descriptions and icons and tags that help for searchability. That's all just generic annotation metadata in the API object. And then on the right-hand side, we also introduced this labels section, which these are not labels on the template itself. These are labels that will be applied to all the objects created from the template. And this is the way that we can then later select and say, okay, I want to see everything created by the Ruby sample template. You select on that label, every object will have that label, and you can see them all, delete them all as one thing, or just see that they're all available. Okay, so then we move on to the body of the template. So here we just have an array of objects. These are your actual Kubernetes or OpenShift resource objects in an array specified. So you see here we have a service defined, and then it's just your standard Kubernetes JSON or YAML for defining a service object. We also have a deployment config, so again, it's an array, as many of them as you want, just whatever you need to define all the components of your application. And then kind of the magic of the templates is the parameters section. And this is what enables you to make that template customizable. So on the left, we have the definition of the parameters. So we've got the name of the parameter, in this case, MySQL user, MySQL database. We've got a description that's, again, going to help the UI present to the user what these parameters are so they can fill in an intelligent value for it. And in this first example on the top, we have generation capabilities. This is specific to OpenShift templates, where instead of forcing the user to type in a value, we can actually generate a value. And in this case, we're saying we want to generate the value from an expression, and it's a sort of regex-esque syntax. So if you wanted to auto-generate a password, for example, you could just say this parameter will be generated in this way. And the user could also override the value, but if they don't want to fill anything in, it just works for them out of the box. And on the bottom, we have an example where there's a default value being provided. Again, at instantiation time, the user might choose to override that value, but if not, you've given them a useful value that will work for your template. And then the required value, we will audit the template at instantiation time to ensure, if required is true, that the user has provided a value that is not empty string. So some values might be optional, but if it's not, this will again give some user feedback to make sure they haven't munged up the process of instantiating the template. And on the right-hand side, you see where we actually use these values. So we've got a substitution syntax, which is $, squiggly bracket, and then the matching name from the parameter definition. And I'm showing this as environment variables. You can actually reference these parameters anywhere in the template body, with the caveat being that it only works in OpenShift templates for string fields. And that's basically because we need to be able to quote the $parens value, and if you have that unquoted, it doesn't work. And if you have an integer that's unquoted, it doesn't work. So a little bit of a JSON struggle there. I'll talk about how we're addressing that in Kubernetes later, but for now, limited to strings, but any string value. So again, if you wanted it to be a label or a service name, you can substitute those as well. So at processing time, we're going to go in and just replace all those references with the value that either the user provided or the default value that the parameter defined, or generate a value and substitute it based on how your parameter was defined. All right, so you've created a really awesome template. How do you use it with OpenShift? First off, we have the endpoints for storage. Like I mentioned, this is just considered a REST resource in the OpenShift system, just like a Kubernetes resource. The OC tool, for those who aren't familiar with OpenShift, it's the OpenShift equivalent of kubectl. Has all the same functionality as kubectl plus the additional capabilities that OpenShift adds on top. So if you want to store the template in the system, and storing it in the system makes it available for other users to instantiate, they'll be able to actually see it in the UI, which I'll show you later, and they can just reference from the command line. So if you want to make it available to other people, you can store it in the system through just a standard create command. If you want to see what templates are available, OC get templates, just like any other resource, and you can also delete them just like another resource. Now, once you've stored it in the system, you want to actually instantiate it. There are a couple of options. OC process is a command line tool which will just process the template, meaning do all of the substitution and return you the objects that were in the template with the substitution complete, so you can then pipe that to an OC create and it'll create everything. If you want to do it all in one shot, we have a new app command built into OC, which is kind of our Swiss Army knife of application management, but one of the things it can do is take a template and do the full instantiation and creation of all the objects from that template. You can also actually, via the command line, override these parameters. So if you just run this as is, you're going to get the default or the generated values for your parameters. But if you wanted to, at command line instantiation time specify it, there's some arguments that allow you to say, for this parameter, I want value foo. Okay, going to try to do a demo. I've got screenshots if it doesn't work, but we'll hope for the demo. So this is our OpenShift console, and I have currently nothing in my project. Projects are the equivalent of namespaces, and I'm just going to go ahead and add something new to my project. And this is a list of actually a couple of things, but among other things in here are templates that have been created in the system. So these are templates that are stored in etcd and are available to users who want to instantiate them. And so the template I'm going to select is what we call our Node.js Mongo example. This template provides a build configuration that can build Node.js applications and provides a Mongo database service and links the two together. So if you have a basic Node.js application that wants Mongo, you can use this template and get all of that. So once we select this template, we see a little bit of the descriptive information that came out of the template definition. We're told what images this template is referencing. So we see it's going to use a Node.js image as well as a Mongo database image. And here we see the parameters that we defined. So if we wanted to configure a different memory limit, both for the application container as well as the Mongo container, we have the ability to specify that. I mentioned earlier the source URL. So here, if I didn't want to build the canonical Node.js example app, I have my own fork of this or my own application. I can just substitute that value instead, and I'll get my application built. We also allow you, if you don't want to build off master, you can put in a different Git ref. We'll check out the appropriate ref at build time and build that instead. I'm not going to put in a host name, but if you wanted to put in a host name, then that would change the route that we configure for you to that host name. We also provide integration with GitHub so that if you commit changes to GitHub, it will trigger a build, and so you can provide a secret for linking that up. And also the service name that we're going to create. So again, if I wanted to have multiple Mongo database services in my project, I would need to use different names. Here's an opportunity for you to choose that name. We're going to let it generate the Mongo database username and the Mongo database password. And we don't care about the database name. And so with that, not actually changing anything, we'll go ahead and create. And if we go back to the console, we now see that it has constructed for us a Mongo database service and a Mongo database deployment config, which is going to proceed to deploy a replication controller for the Mongo database. And we also see that we have a service for our Node.js application, and we have a build that's currently running, or a build that's actually completed just now, which has built a new Docker image with the code from GitHub on a Node.js runtime, and it's deploying it here. So that has just completed. And now we'll see if we can actually access that thing. Because I didn't set up a route, I'm just going to go in through the service IP. And here we see that we have our Node.js application, and we have our database connection information that we are connected to the database service. I think my sacrifice to the demo gods must have been successful. So don't care about that. You've now seen it all. Okay, so that's OpenShift templates. Our our next step was, okay, we think this is pretty cool. It would be even better if this was part of the Kubernetes community so that there can be more tools written around processing templates, editing templates, more people creating templates in the ecosystem that do cool things. So we have upstreamed this. The proposal has been accepted. The implementation is yet to be started, accepting volunteers, but it will basically be a port of what's been done in OpenShift. There were a few tweaks. During the discussion, there was a lot of debate over what should Kubernetes actually have as a core function, and does this belong? Or should Kubernetes really just be more of an orchestration engine and people should layer this kind of stuff on top? Part of that led to the conclusion that the acceptance of Kubernetes templates was not so much to focus on application topologies like OpenShift used it for, but to focus on using it for internal components so that you could have something equivalent to a replication controller that instead of just stamping out instances of pods, it could stamp out instances of the topology. And so things like daemon sets and pet sets could become more sophisticated, where instead of having a daemon set or pet set of pods, you've got a daemon set or pet set of a service and a replication controller and a route, and maybe multiple services or multiple replication controllers. So that's one of the ways that Kubernetes is intending to make use of this, is actually internally for those kind of scenarios. That also led to the idea that, well, maybe the name isn't even quite right. It's really a parameterized list rather than a template. The parameters being the substitution process and the list being the list of Kubernetes resource objects. So you may hear it referred to as parameterized list. We'll see if the template name or the parameterized list name is what actually sticks. The biggest actual difference in the implementation is it was decided generation, the password generation capability that I mentioned in OpenShift Templates, didn't really belong. Kubernetes wants to do secret generation as a feature, and so that will also be coming, and the idea would be that you would just use that secret generation mechanism from within your template rather than having the template language and processing itself support that generation. So that won't be there in terms of as a parameter function. And the other bit is, I mentioned earlier that the OpenShift templates only support string substitution, so we are going to have a mechanism for supporting other parameter types, so you can have your integers, base64 encoded data, things like that, substituted in to your fields. All right, more JSON, hooray. So what does this look like? Well, it should look somewhat familiar to what I showed you earlier with the OpenShift template, but the parameter section being slightly different, with, you see, there is a type field, type integer in the lower left there. And that actually is not what determines whether it gets substituted in as an integer or a string or not. That is really more of a hint to user interfaces built around this template to tell the user what kind of value is expected here, or do validation of the value provided by the user. Where the actual type of the substitution is determined is, you see that we've changed the syntax slightly from $squiggly bracket to $parens. That's to align with the fact that Kubernetes was already using $parens for environment variable substitution in resource objects. So we're using one syntax everywhere. If you do $double parens, the quotes are going to be stripped out. And so that's why you see that the replicas case, we have $double parens, so that after substitution, you'll be left with replicas and an unquoted value. And if you do $single parens, then you get the quoted string. Just some more detail on exactly how that syntax works, because it is a little bit confusing. But in the first example, we've done single parens, and so you end up with your field and a quoted string. In the second case, the quotes are going to be stripped out. If you can do concatenation as well, or embedding of the value. So in that case, it's still going to be based on the type of substitution you're doing within that string, whether the quotes remain or not. And if you work in test and you're trying to break things, so you decide you're going to do both of them, we're just going to keep the quotes because it's arbitrary and you really haven't made it very clear what you were trying to do. So that's what's coming to Kubernetes as soon as we can get some resources around implementing it. But if that is not meeting exactly your needs, turns out there are lots of other external projects that are not built into either Kubernetes or OpenShift that are also trying to solve the problem of application configuration and deployment management. So depending on which one you pick, some of the benefits you might get are more sophisticated templating languages. So you want to be able to do things like actual logical if conditions or loop conditions within your template processing, or more complicated parameter management. You might be able to, you don't like $parens and JSON, well, you might be able to use JSON or you can use Python in some cases, or whatever templating language you prefer depending on the project that you pick. Some of them also support includes and dependencies, so you can build up hierarchies of templates where a template is defined in terms of 3 other templates. The downsides of picking something that's not built into the core component system is more sophisticated templating. It's sort of a double-edged sword there. So you can certainly do more, but it tends to make the syntax more complicated, a little bit harder to write them in the first place. It also means that you are buying into a separate set of tooling that you're going to have to manage and upgrade independent of the core runtime. And it's not going to be as tightly coupled into your user experience in terms of things like being able to store the templates in the etcd system, use the command line tooling to instantiate or view your list of templates, whatever web console support Kubernetes ends up adding for them, but certainly the OpenShift web console support for templates is pretty strong. So that's what you lose when you go to an external template system. So what are a couple of options? This is only a small sampling. The ecosystem, it seems like every week there is a new one. I couldn't keep up with all of them, but Helm is certainly one popular one. And Deis is here. They have a booth, so you can ask them all the questions I can't answer about Helm. But the basics are they call their templates charts. They use a Git repository-based system for managing them. So you have a Git repository in which you store those charts. And a chart is defined with one YAML file that has some metadata describing what this chart is. And then it has a set of up to n Kubernetes YAML files that are actually just resource definition files. So a service YAML, a replication controller YAML, etc. They do support hierarchy dependencies, so in your chart YAML, you can actually reference other charts that you are dependent on. I don't believe they have parameterization. It's just a Kubernetes resource object, so there's no way to parameterize it unless you wrapper more logic around it. So what does a Helm chart look like? Here we've got the hierarchy of the directory, so you've got a directory containing that chart YAML, and then a subdirectory called manifests contains the actual resource YAML definitions. And on the right, we can see what the metadata YAML file looks like. So we have just your name, some generic metadata. If you wanted to have a dependency, that would also be listed here. I didn't pick an example with a dependency, unfortunately, but that's where you would define it. And then if we look at what the service YAML look like, it's exactly what you would expect. So in this case, it's just defining a Kubernetes replication controller with very hard-coded specific values of what image is it going to run, what ports it's listening on, labels to apply, etc. Pulled these directly from the Helm website as far as how do you use it, and I guess that is legible. So they give you the ability to search for things based on key names, so you can find a chart that is Redis or is Mongo or is Node.js. You can get information on the template you found, which is basically just displaying you the metadata YAML, so it hopefully tells you some useful information about whether that chart is in fact the one that you were hoping for. You can then install that chart into your cluster, so this is actually going to go create all those objects that the chart defines in your Kubernetes cluster. And you can actually see it shows you the kube control command that it's running. And by the way, this will work if you have an OpenShift cluster as well, because OpenShift includes kube control and it supports all the same API endpoints that Kubernetes supports. So I actually ran through this example on my OpenShift cluster, works perfectly well. And then you can manage your repository of charts, in this case, adding a chart from a GitHub repo to your local library of charts that are available that you could install into your cluster. All right. The other project I want to talk about is Deployment Manager. This is a project run by Google. And so this is sort of the mother of all templating and deployment management systems, from what I can tell. So offers you a choice of Jinja or Python syntax for defining your templates, so you can do incredibly sophisticated things. It is extremely hierarchical. It tries to build up from very basic components and assumes that you construct your templates using those components and layering until you have an entire system defined from those. Because it's Python or Jinja, the template syntax is incredibly flexible. Obviously, you've got an entire programming language in your pocket for how you want to define those templates. And it also intends to solve the problem of reconciliation or redeployment, which is something that the other templates I mentioned do not handle. So if you change this template definition and you want to apply that delta to your cluster, Deployment Manager intends to solve that problem. I don't actually know today if it does, but that is sort of one of their goals, is to be that whole end-to-end system of make changes, apply, iterate on it. All right, so what does a Deployment Manager definition look like? Well, at the top level, we're defining here our basic resources. So we've got a front end, and which is defined as type replication service, and this is where we start to see the embedding. So we don't care what a replicated service is, but we say we want a replicated service and some properties that we're going to pass to that replicated service. So we say we want this replicated service to operate on port 80. We want it to be an external service. We want 3 replicas. And what image is that replication controller, which is ultimately what's being produced here, going to run. We specify that. And then we also are defining another component, which is going to be a Redis backend for the system. And that is defined actually as just type Redis, because that is another hierarchical component that is defined that we can just reference as a whole, assuming that you like the way that that Redis component is defined. So now we drill one level deeper, and now we're going down into that Redis type that was defined. And so we have the schema for the Redis type, gives us some information. It's a Redis cluster, tells us it defines a replicated service with masters and slaves, and it supports one property, which is the number of worker replicas you want, defaults to 2. And then this is the actual logic that backs that schema. So in this case, done via JSON. We've got, you can see where some of the parameters come into play here. And again, it's actually defining it in terms of another type. It's defining it in terms of the replicated service type that we saw earlier. And it's going to pass a few parameters to that, including the number of workers, which was the parameter that this component took, is going to pass down as the number of replicas to that replicated service that it's going to instantiate. And we're also telling it again which image. I haven't shown you the entire template here, so this is the slave portion of the Redis template. There is also a master portion, which, as you can imagine, would use the Redis master image instead of the Redis slave image, and only has one replica. Sorry, yes, yes it is. I'm sorry. So now we're drilling down into the replicated service definition, which was referenced previously. So again, we have a schema for that defined, description of it, some properties. In this case, again, it takes the container name, which we saw we were passing from the upper layers down. What container are we running in the pods that are created by this replicated service? And also the service name that's going to front that thing. And then one more template. In this case, I have severely excised the content, but this was actually a somewhat lengthy Python program. And the ultimate goal of what this Python program has to do is define the Kubernetes resources that it wants to instantiate. So you can see a little bit of it here that it's defining a service object, and it's ultimately going to return that to the template processing system so that it can instantiate it. And so this is where you get the maximum amount of flexibility. You've got Python at your disposal, whatever you need to do in Python to define your Kubernetes resource object that you want based on parameters that were input or the time of day or whatever you want. That's all available to you. So as it turns out, in what I think was a conspiracy to disrupt my presentation, Helm and Deployment Manager actually announced they are merging this week. So if you liked some pieces of Helm and some pieces of Deployment Manager, great news, they are now one thing. So charts will now be deployable via Deployment Manager. I believe they are also, Deployment Manager is going to sort of adopt some of the Helm tooling. So I don't know all the impacts of what the merge is going to result in. Again, you can speak with some people at the Deis booth who can probably tell you more, but that's what's happening in that space. So, all right. So to wrap it up, don't define raw resources. Create templates. That way you can reuse them. You can customize them. Everybody can use them everywhere. You build the ecosystem. Great thing about standards, as you all know, there's so many to choose from. So if you don't like any of the ones I've talked about, there are a few other options. Just a couple of names that I know of is Noel, RedSpread, Kdeploy. I believe there's a talk about Kdeploy earlier in this conference. And I'm sure there are others. If you want to keep on top of what's going on in this space, join the SIG-config user group. That was where we discussed the Kubernetes template upstreaming, and other of these projects come up and do presentations during that. Just some links to the projects that I talked about, and that's all I've got. Any questions?
Any questions still? I've got the mic here. Steve?
Hi. Dependencies. When you have your application configuration file and you're setting up various different pods, RC services, are you able to define sort of dependencies between them so that, for example, if you had, let's say, a Redis cluster that you wanted to spin up before some of the other ones, is that possible at the moment? Is that on the roadmap?
So if you defined it within the template, there is no explicit ordering in terms of how those things are processed, although you can have, for example, a readiness check to ensure that your application pod doesn't actually become ready until its equivalent database. But if you just want to be able to say, I can't instantiate this template unless you've already defined a Redis cluster somewhere else, that is not a capability that's in there today, no.
Any more questions at all? Going once? Going twice? In that case, join me once again in thanking Ben for this time. Thank you, Ben.